Here's an example of solving an equation with rational expressions. So here's our equation, 9 over y minus 1 plus 1 over y equals 11 over 10. And one good way to solve an equation with rational expressions like this is to clear all of the denominators. If you can get rid of all of the denominators in the problem, then the equation will be a lot simpler. And to get rid of multiple denominators at once, you need to find the least common denominator. So let's find the LCD for all of these denominators. We have a y minus 1 in our first fraction, so we'll need a factor of y minus 1. We have a y in our denominator in the second fraction. We don't have a factor of y yet, so we need a factor of y in our LCD. And in this last one, we have a factor of 10 in our denominator, so we'll need a factor of 10 as well. This 10 is actually optional. If you're willing to do a lot of fraction arithmetic, we could leave this denominator 10 alone, but it'll make it a little easier to get all of the denominators, even this 10, out of the way. So our LCD is 10 times y minus 1 times y. Now what do you do with that LCD? We are going to take this entire equation and multiply both sides by the LCD. So multiply both sides by 10 times y minus 1. All right, so let's write out what that is. The important thing to remember with multiplying all of this stuff is that we will have to distribute it to every term on both sides of the equation. So that's going to give us 9 over y minus 1 times the LCD, which is 10y times y minus 1, plus 1 over y times the LCD, 10 times y minus 1, equals 11 over 10 times the LCD, 10y times y minus 1. All right. Now, I bet you're itching to cancel some stuff, and that's good. The whole point of multiplying by the LCD is that a lot will cancel when we do that. So this, in the first term, this y minus 1 cancels. In the second term, the factor of y cancels. And on the right-hand side of the equation, the factor of 10 cancels. So let's see what that gives us. In the first term, we have a 9 times 10 times y, so that's 90y. In the second term, we have, let's see, a 1 times 10, so 10. The y canceled, 10 times y minus 1. And then on the right-hand side, the 10 canceled, so we have 11 times y minus 1. All right, so this is starting to look better now that all those denominators are gone. It looks like the sort of equation where if we just multiply everything out and combine like terms, then maybe we'll be able to solve. So let's do that. Let's multiply everything out. On the left, we have 90y plus 10y minus 10. That's distributing this 10 right here. And then on the right-hand side, we need to distribute this 11y. We get 11y squared minus 11y. All right, sure enough, it looks like the sort of polynomial equation that we can solve by combining like terms. So let's get everything to one side. Let's see, these first two terms, I see that together they make 100y. So let's subtract 100y from both sides. And while we're at it, let's add 10 to both sides. So on the left-hand side, let's see, the 10y plus 100y, sorry, the minus 100y cancels the plus 100y, and this plus 10 cancels the minus 10. So on the left-hand side, we are left with just 0. And on the right-hand side, we have 11y squared. Looking at our y's, we have minus 11y minus 100y. That's minus 111y plus 10. All right. So this sort of equation, this is the sort of equation that we can solve by factoring. So let's try to factor. So using our AC method, 11 times 10 is 110. So we're looking for factors of 110 that add up to negative 111. And there aren't, I mean, the most obvious one is minus 1 times minus 110. And that, sure enough, will work, because when you add those together, you get negative 111. So we can use this minus 1 and minus 110. We can use that to split up the y's in the middle. We get 0 equals 11y squared minus 110y minus 1y plus 10. All right. Now on the first two terms, we're looking for a common factor here, and it looks like they have an 11 and also a y in common. So factor out the 11y, and the stuff left over is y minus 10. And in these second two terms, we're looking for a common factor. It looks like they don't really have a common factor, but remember, usually in these situations, we want to factor out this minus sign here. So let's factor out that minus sign, and this leaves us with y minus 10. Careful with your signs there. Okay, now both of these terms on the right-hand side have y minus 10, so we can factor out y minus 10. So factor out y minus 10, and the stuff left over is 11y minus 1. Now that we have the left-hand side being 0 and the right-hand side is a product, we can use the zero product property. So we get either 0 is y minus 10, or 0 is 11y minus 1. Now just finish solving each of these. So on this first one, we can add 10 to both sides. On the second one, we can add 1 to both sides. So the first one becomes 10 equals y. And on the second one, we get 1 equals 11y. So our first one, 10 equals y, that's solved already. For our second one, we still need to finish isolating y, so divide both sides by 11. So we get 10 is y, or 1 over 11 is y. So we have two solutions. Y is 1 over 11, or the other possibility is 10. And that's how you solve a rational equation.